Again, us algebra teachers might be on different paces. Generally, like I tend to have the most math lab kids, like meaning like they're also in my algebra. That's usually how it's set up. So usually I just base it off of whatever my algebra students are doing. So that's why. And usually everyone else follows my pace anyway. But this week it's a little bit out of order, so I think most other algebra teachers did the lesson 8 and 9 today, which is what we did the Kahoot on yesterday. That was that skill. Today we did connecting equations to graphs in my class, which is lesson 10. Whatever it is that you did in your class, like you basically have a to-do list by the end of the week. You'd be getting 80% or higher on lessons, the multi-step equations, which we already did, the 8, 9, 10, and 7. So tomorrow you'll have like that to the whole hour. Yeah. It's obviously really helpful after. So today's lesson, for those that are not familiar with lesson 10, is super important. So if you haven't had lesson 10 yet, make sure when you get to it, it is like so far the most important lesson. This unit is called linear equations. We're just getting to the part that makes it linear. All up to now, we've just been focusing on how to make equations, how to solve them. Now we're actually doing the part that makes it linear. So when you hear the word linear, what should you automatically be thinking of? A straight line. What equation do our straight lines always have? Usually like the only equation you guys remember from middle school. So here's examples of linear equations. They make straight lines when you graph them. But what is the formula for them? Yeah. Good. That's the one that people tend to know the most. There is another form, and that form we looked at today, and that's our standard form. So up here is our slope-intercept form. Guess what we can see in our slope-intercept form? It's in the name. Slope, good. Which letter is up for our slope? Just the M. But you know it's the slope because it's always in front of the x. So even if I write things out of order, like here would be this order, here would be a different order. 2 would still be my slope because it's the number that's in front of the x. Okay, so it doesn't matter what order they write it. If the y is isolated, it's in slope-intercept form, and the slope is in front of the x. What else can you see really easily from slope-intercept form? It's the other word in the name. And which intercept specifically? The y-intercept. The y-intercept is which letter? The B. I know it's weird, but that's how it is. Now the x and y, so keep paying attention, the x and y are just any point on the line. So like usually the only thing replaced with numbers is the m and the x. The x and y would be like any combination of coordinates that is on the line. So there's that. That's our slope-intercept form. That has the pros and cons of being able to see the slopes and y-intercept. For our standard form, so like for this form, A, B, and C would be numbers. So like an example of standard form that I was thinking of would be something like 4x plus 2y equals 30. Just made it up. So that works for situations that, like if you have to make a word problem, most word problems that are linear will have a setup like that. Not all of them, but a lot of them. So something like this. Let me pause. Sorry, pause. No one ever calls me, so when they call me, it's like important. So give me a second. Hello. Hello. So for our standard form of equations, this is good for like word problems. Like this could represent maybe they have $30 to spend at the store, so maybe that's their budget of $30. And they're buying something that costs $4 and something else that costs $2. Combined, that contributes to what they're spending, right? And the value of X and Y would be like how much they buy of each or whatever. So this is helpful for understanding whatever story is going on. The other is helpful for actually graphing. Now, we haven't actually talked about how to graph. In the lesson today, we talked about how to graph from standard form. If we plug in 0 for the X, solve for Y, we get our y-intercept. If we plug in 0 for the X and solve for Y, we get our, or I think I said that wrong. If I plug in 0 for the Y and solve for X, I get my x-intercept. And that's about the extent. So we will get into how to actually graph from slope-intercept form, but not today. So right now you're just going based off what we did, which is plugging in like a 0 if they go on 0 rides, how many games did they play, like just plug in and solve. But that's what we did. And we're kind of seeing how on the graph of the equation, we could see the y-intercept, we could see the x-intercept, we could start seeing the slope and what it means about the situation. So there's a part 2 of this lesson, but that will be next week. Okay, so I'm going to put up the to-do list because some of us are on different paces. This will be the same to-do list you have tomorrow. And remember, like the kids that do their own work are the ones that do well on the quizzes and on the tests. So while you could probably easily cheat, you should not be. That's not what this class is for. Getting 100% on your homework means nothing if you're failing the tests. All right, so this is your little to-do list of things that should be at 80% or higher. Today, my students did less than 10. Other students probably did 8 or 9 today, but by the end of the week, this all needs to be 80% or higher. Questions? Okay, one. It's this one, right? We have the same number 1. Okay. So we're matching each equation with an equivalent equation. Some of the answer choices are not used. So equivalent would be like if I can manipulate it to get the other. So like maybe if I start isolating things, distributing, combining like terms, just kind of see what you get. So, or you could even try and compare like this first option that's on my screen has it has a 9x on the left side. There's no way I could do that to this because the 4x plus 7 is still on the right side, so it can't be belonging to that first one. For this next one, if I distribute this 3, I get 3x plus 18, which is not 9x, right? So still not that. And then when I look at my last option, if I were to move the 4x onto this side, I'd have to subtract it. So like this one, I don't think goes with any of them. So that's kind of how I'm trying to figure it out. For this next one, this one is what I get after distributing. So distributing just changes the side that you distribute on. The right side should stay the same like this side. And when I do distribute, you're multiplying. So 3 times x is 3x, 3 times 6 is 18, so that's gonna match there. Make sense so far? And then for this option, it looks like for like if I was comparing this one that the 6 is gone, but whatever they did on the left, they didn't do on the right because the right side is still the same. So it doesn't go with that first one. For this one down here, 4x plus 3x is 7x. Like, this is just not making sense. Like, that doesn't match that one either. So now we're on this option. Let's see. 3x minus 1 equals 4. So it looks like they got, or 4x, I should say. It looks like they got rid of this 7. So how would I have to cancel out this 7? Good. And then whatever you do on one side. Good. So one side of the equal sign, you just have to do it once. Notice I lined it up with its like term. So it does nothing to the 3x. What is 6 minus 7? And it's a -1, so I'm going to put -1. On the right, this cancels and it's just 4x. So that is how I'm getting this as a match by moving the 7 to the other side. And that's what I get. Now, the only one is left. We already ruled these two as not belonging to the one that's left. So this must have to go there. But that makes sense because if I were to combine like terms on this side, these both have a variable. You can combine them. What's 4x plus 3x? Good. And then the right side, if you combine these are also like terms. 7 minus 6 is, that gives you this. That makes sense? Okay. Any questions on any of the practices so far? Gracie? Lesson 8, question 2. The one that says a chef bought?
Yeah.
Okay. So a chef bought $17.01 worth of ribs and chicken. Ribs cost $1.89 per pound and chicken costs 90 cents per pound. That equation represents the relationship between the quantity we're solving. So whenever they say solving for something, they want that isolated on one side. So we're gonna start isolating this. So look at everything that's being done to the C and get rid of what's farther from the C. What's farther from the C? Give me 1 second. Okay, sorry. If you're having side conversations, please stop recording. Yeah, we'll have it. So what's farther from the C, the 0.9 or the 1.9 or 1.89 R? And how would I cancel that out? And whatever I do on one side of the equal sign. Good, so this will cancel it out here. I have just the 0.9 C on the right. Are these like terms? Like, do they have the same variable? No, one of them doesn't even have a variable, so you can't combine them or anything. All you can do right now is rewrite them. And then on this left side, what's the opposite of multiplying 0.9? Whatever you go one side. And we're doing it to this entire side, which is the same as doing it to each term individually. So we will have to reduce this and reduce that. But for the C, I'm alone on one side now. This part I need to put in my calculator, so 17.01 divided by 0.9. I get 18.9 for that. And then this, I don't know if I can really simplify it. Let's see what so I have the negative 1.89 divided by 0.9. Let's make that a negative 2.1. And it's still being multiplied by the R. Now, the way this is set up, so what should be alone on one side should be the C. And the way they have it written is they have the variable being like the first term. So I just need to switch this order. I'm allowed to switch the order so long as I keep the signs that are in front of it. So like this is a positive 18.9. For this one, they want you to write it second instead of first. And then this is a negative 2.1 R. And as long as I make sure I keep that negative in front of it, I can switch the order. And that is how to get that part completely right. Does that make sense so far? Okay, now for what would you want to solve? Oh, why would you want to solve for C? And it's a drop down. To make it easier to find, and then this is where it starts to be different. Pounds of chicken or pounds of ribs? What was C representing? Yeah, I mean, that's what makes sense. R for ribs, or I feel like it's missing some instruction. But, yep, it will make it easier to find the pound of chicken if we know how many pounds of ribs were bought. And then that's how you get it. This one. Questions on any of the practices? Think of anyone. Bill, yes.